Freshwater is a critical resource that is under pressure from increasing global populations and climate change. To make sure that we look after freshwater resources, we need sensible strategies to assess and manage rivers. Environmental flow, E-flow determinations of rivers, are crucial river assessment and management tools that quantify water requirements for maintaining the integrity of rivers, aiming to balance human and environmental water needs. Understanding the physical profile above and below the surface of the water of a river is a core part of E-flow determinations.
In order to do effective hydraulic modeling of rivers, you need to gather as much information about the river systems as you can. This is traditionally done using cross-sections, which is a very manual, time-consuming exercise.
The cross-section that we survey in the field is the starting point to the hydraulic modeling of the study. We generate the cross-section by measuring the elevation as well as the horizontal distance across the river. We also measure the discharge as well as the slope of the water. All the data that we collect is then put into the HAP-flow model. The HAP-flow model helps us to understand how different flows and depths of flow affect the habitats of the fish and macroinvertebrates that live in the river.
The research and development that GroundTruth are doing within the CGIAR Initiative on digital innovation has shown that it is possible to significantly improve E-flow assessments using a drone-tethered boat device that collects data for an entire reach of a river as opposed to a single cross-section. The boat that we constructed and equipped with a suite of water quality and water depth sensors collects data in real time and simultaneously.
This technology offers an exciting alternative to river assessments because we are able to access challenging reaches of a river and get large volumes of high-resolution data at a relatively low cost. In this project, we are using various types of sensors such as sonar and LiDAR, but specifically attached to drones. So we are doing this to capture data on a whole stretch of a river and to understand river dynamics in far more detail than was ever traditionally possible.
So while the device is in the water, we collect temperature data and look at the depth below the water surface, and once that's done, we process and stitch to the terrestrial LiDAR data.
Using the new drone technology, we are able to gather very accurate data about river systems, and that increases our confidence in our modeling, and ultimately we can provide better recommendations going forward and have more confidence in our management structures that we put forward for river systems.
This environmental flows data, the UAV derived data is feeding into the digital twin and giving us a broader picture of how the digital twin can reflect these data and make that data available to water resource managers to better manage flows and floods in the system.